In this video, I'll be going over the answer key for March 31st. And we're talking all about energy today, so we need to learn some definitions about energy to truly understand energy in a chemistry context. So first, what is energy and what is work? Energy is the ability to do work, and work is a force over a distance. So if you're just holding onto a weight and not moving the weight, you're not doing work. As soon as you move the weight, you're moving that over a distance, so now you're doing work. What is kinetic energy? That is energy related to motion. What is potential energy? That's energy of position or composition. So think of the higher you hold something, the more potential energy it will have, and when you drop it, that potential energy goes to kinetic energy. Thermal energy is the energy of heat, it's temperature. Chemical energy is the energy in bonds in atoms and molecules. What is the law of conservation of energy? The law of conservation of energy says energy cannot be created or destroyed. It can only change forms. How does that relate to energy exchanges? So if you have a system in a surrounding, and let's say a system loses 20 kilojoules of energy, that energy must go to the surroundings. So any energy lost or gained by a system, the same amount must be lost and gained by the surroundings, just opposite sign. So if the system gains energy, the surrounding lose energy. If the system loses energy, the surroundings gain that energy. What is a state function, and what's an example of a state function? A state function is a variable that only depends on the initial and final values and not the path you took to get those values. So energy. All you care about in a calculation is the final and initial energy. You don't care what happens to the energy in between because it's a state function. Same thing with enthalpy or heat. Does not matter what happened in between the start and the finish, only the start and the finish. Same thing with entropy, which is chaos. Does not matter what happens in between those measurements, just the beginning and end of those measurements. So if energy flows out of a system into the surroundings, what's the sign of delta E? Well, if energy flows out of you, you're losing it, so you have lost energy, so you're negative energy now. And exothermic, exo means like exit, so if energy is exiting you, you're exothermic. Endo would be inside, entering, energy is entering you, but we're losing energy, so it's exothermic. So let's talk about energy in chemistry. So if the internal energy of the products of a reaction is higher than the reactants, what's the sign of delta E? So delta E for chemistry is always products minus reactants. So if products have a higher value than reactants, delta E is positive. That means it's endothermic because energy needs to go from the surroundings into the system. 3. For these energy exchanges are the heat or work, and what's the sign of delta E? So we have a billiard ball hitting another billiard ball. The first energy is the system and stops. So this is work, and delta E is negative. All the energy in the first ball was transferred to the second ball. So that's why it's a loss of energy. And basically, for these, if we don't have a temperature change, we're never doing heat, so this is work. A book falls from the floor. So at the higher you are, the more potential energy you have. So we went from a high height to a low height. So we lost potential energy. So that means delta E is negative, but again, we're doing work. A father pushes his daughter on a swing, and the daughter and swing are the system. Again, this is work energy. We're not changing temperature. And if somebody is pushing you, you're gaining energy. You'll feel that because you'll move because of the energy. And so delta E is positive here. Right. A system absorbs 196 kilojoules of heat, and the surroundings do 117 kilojoules of work on the system. What's the change in energy? So our equation here, and it's a little faded from my writing, delta E equals Q plus W. Q is heat, W is work. So delta E equals 196 kilojoules of heat because it's absorbing it, so that's a positive value. The surroundings is doing work on the system, so that's also a positive value, positive 117. So 196 plus 117, because these are both positive values, delta E is 313. Question 5. The air in an inflated balloon, which is your system, warms over a toaster and absorbs 115 joules of heat. As it expands, it's doing 77 kilojoules of work. All right, so here's my drawing of a balloon. It's absorbing 115 joules of heat. So if it's absorbing heat, heat is positive. And it's doing work. So if you do work, you're losing energy. So work is negative. What we need to be aware of are the units. Kilojoules is 1,000 joules. So if I have 77 kilojoules, that's 77,000 joules. When I'm adding or subtracting, I have to be in the same unit, so I put both of these in joules. So I have 115 from the heat, positive value, minus 77,000 from the work, because I'm doing work. So in total, this answer is negative 76,885 joules. You can ignore the bottom part. That actually goes to question 6. So question 6, we're using our equation of heat equals mass times specific heat times delta T. Now, when you see delta, that always means final minus initial. CS is a specific heat capacity, and those are constants. M is mass. So we can really relate heat, mass, and specific heat temperature and our specific heat capacity and change in temperature with this equation. So let's figure this out. If I have 250 milliliters of water at 37 C and I absorb 342 joules of energy, what's my change in temperature? First off, our temperature change should go up. If you're absorbing heat, you should get hotter. So we should be above 37 degrees when we finish calculating this. So the first thing we need to do is set up our equation. So we have Q equals MCS delta T. I took my density, and that was actually, let me go back. So that's what this is. So Q equals MCS delta T. Our density is 250 milliliters. For every 1 milliliter, we have 1 gram of water. So the weight of our water is 250 grams. And delta T, like I said, is T final minus T initial. So let's go back to this problem. So Q heat was 342. Mass is 250. From our table, we can see CS is 4.184 and delta T. Well, initially, we're at 37, so that's my T initial, and we're trying to figure out T final. So what I did was I multiplied 250 by 4.184 to get 342 equals 1046. Divide each side by 1046, and you get 0.33 equals temperature final minus 37. Add 37 to each side and you'll see, oh, the temperature final is 37.33 Celsius. So our temperature did go up, like we said, and that is how you use Q equals MCS delta T. And that's all the questions for this problem set. If you have any questions or confusions, please don't hesitate to contact me. Otherwise, I'll see you in the next video.